All right. So I was asked to give a talk on CTV, and the topic is CTV Revisited. And I struggled a little bit to come up with this talk because it's kind of boring from my perspective, because this is all stuff that I already know. So revisiting my whole life story. But first of all, what I realized is happy CTV could have been active 2 years ago day. I don't know if that was intentional, the scheduling of this, but that was the original proposed activation date. So I'm going to give this brief historical overview from my egotistical point of view of having worked on covenants for a long time, sort of how I saw things shape out and play out. And that maybe will help contextualize, those who don't respect the past are doomed to repeat it in some way, shape, or form. So perhaps this will be useful, although it makes me feel very, like a dick for being let me tell you about everything that I think I did. So it started off for me with covenants. I read some of the papers and knew about the research, and then I thought they were really neat, but saw that it just wasn't happening because everybody thought that covenants were evil and bad. So in 2017, I was invited to give a talk at BPace by Byron on, hey, whatever you're thinking about, give a talk. And I said, okay, well, I'm really interested in covenants. Let me give a talk that's only on safe covenants, things that shouldn't annoy people who like Bitcoin a lot, and who kind of came up with all the reasons why covenants were bad. So I gave this talk. It was relatively well received. And then from there, I was let's maybe start implementing some of this. And I came up with this little mini GSR fork that had all these different things I was excited about. I enabled opcat, I had checks from stack, I had get block hash, get input, UTXO exists, all these kind of fun covenant primitives. And then I tried to show people, and they told me to get lost. So I was okay. I worked on other stuff. All throughout this, I'm also doing Bitcoin core dev. I'm consulting. I'm helping out other projects. I'm doing other stuff, but this is kind of just the journey in the covenant space. And then towards the summer of 2018, I said, okay, well, people don't like covenants. What if we could just do everything with pre-signed transactions? And what if instead of trying to say, oh, covenant opcodes are going to be the solution, what if we just build a world where we try and get this all done with pre-signed transactions? I think the last speaker said maybe that's the way forward as well. So I came up with this thing called Lazuli, which was a high-speed ECDSA multi-signature algorithm. And the idea was, okay, you want billions of people to be, using this stuff, and you're going to have thousands maybe per, UTXO. They're all sharing. And if we're doing pre-signatures, it actually turns out that we don't care about most of the security properties of a normal signature. Chiefly in Musig, for example, if you do a signing round and then somebody sends a corrupt message and it leaks your key, that would be really bad. But if it's a pre-signature and they do a corrupt message and it leaks your key, then you just restart with a fresh key. So maybe we can eke out some weird performance there. I don't know if I particularly did eke out the performance, but I did come up with an algorithm for ECDSA, which has this property of you don't have to do these zero knowledge proofs for the MPC, because at the end you either get a valid signature or someone cheated. And if you have a valid signature, no one cheated. So it kind of had this nice property. And then I started writing about, well, what can you do with this? I started writing about sort of the proto-arc thing, these congestion control trees that were how do I explain the basic use case, and we can talk about maybe updating afterwards. But updating is hard. How do you get thousands of people to agree to a multi-sig? You probably don't, but you can get them to agree before you send the money. So I presented this. I remember I went to the the Bitcoin core devs meetup, and I said, okay, I've been working on this for a year, and there's code, and it's would anybody like to listen to my little lecture about it? And people said, we have zero interest in anything ECDSA, Taproot and Schnorr is right around the corner. So why don't you, get lost? I said, okay, well, that's kind of dismaying. I tried to, garner up some interest, but there wasn't really those key endorsements of oh, this pre-signing path is really good for building these payment pools. So then I said, maybe I can take a different approach, and maybe I can just give the minimum possible covenant that could still do something interesting and accomplishes this pre-signing goal with an opcode. So in May 2019, I published opkoshvi, check outputs hash verify, which is really the direct precursor of CTV. And it had a really good response. The people who really hated covenants were this thing is so limited, but you've demonstrated you can actually kind of compose it and build these really useful applications. So this actually might be something we could agree as a soft fork upgrade. It is okay. And it's pretty simple. So from there, I went through a couple rounds of feedback. And that's where it became CTV. So it incorporated, commentaries oh, this is overly restrictive. We can maybe do it a little bit differently. This is also sort of in the lessons of history. When I started really being like, okay, well, what's going to happen when you have like trees that have lots and lots of people? I realized that the mempool is just completely busted. Like the mempool, whoever wrote that code, like made all these mistakes, and they weren't thinking about how Bitcoin would be used, or maybe they weren't like detailing every single possible denial of service constraint. But I realized that like the code had all these algorithmic blowups, and so the limits had to be really small, which would prevent you from using it the way that you might want to use. And then also there were just like bad DOS vulnerabilities. And so I started working. I just got really scared, and I said, I bet if we don't just like fix all these weird algorithms, we're going to like just have the mempool riddled with like denial of service vectors. So I came up with a pathway for like re-architecting the mempool. I wrote it was 150 commits of like rewriting every algorithm. And I think I got 2 of those algorithms committed to core, like overall. So all that code somebody could pick up and like refactor. It would improve the mempool performance quite a lot. But there's just like, it's really slow. It took me for those 2, it took me like a year. And one of them was fixing something that could have bricked the network. Like you can mine a specific sequence of blocks and, attack the mempool. And then it shuts down your node by allocating like terabytes of memory and taking like infinite time to like process the graph that it produces. So it's like bad stuff. And it's just the like iterative speed on like Bitcoin Core fixing mempool bugs is like not very good, because maybe like 3 people actually like understand how the mempool works. Now, where this is relevant and where's the lesson is like when you're building this covenant stuff, actually the mempool really matters. And if you can't demonstrate that your covenant is going to play nice in the mempool, it's actually probably not something that will ever get deployed. Not just your covenant, opcode, you might get that deployed, but the applications built on top will really suffer for not being able to actually go in. So just kind of, rolling through it. In January 6th, so it's my January 6th, 2020, I applied for OpsCTV for BIP assignment. That happened relatively quickly, much faster than OpCat. I think it happened within a couple days. And so then I had a BIP number, BIP 119, and I said, okay, I'm off to the races. I hosted a workshop in San Francisco, and I'm trying to think if anyone who's here was there. Was anyone at that? Oh yeah, we got maybe 1 or 2 people who were at that workshop, and it was pretty optimistic. People were like, okay, this is good. There's been a lot of research. We understand how you can build these simple applications. We understand. We had talks on pre-signing. We had a bunch of stuff. People said, okay, let's have a little vote at the end, not for consensus, but just like what do people think it's going to take? And like the really farthest out people were like, it's going to be like 2 years before you see this stuff. And a lot of people thought it could happen within 6 months to a year based on what they compared with other research. Obviously, that didn't happen, even though there was a lot of people in that room. And then sort of around this time, it got a little bit weird because I was saying like, hey, this stuff is kind of ready to go. Like I've taken all the feedback, I've integrated, I've made a pretty pristine opcode. And then people started saying, hey, if you don't shut the fuck up right now, you are going to stop us from getting Taproot. And we will put that blame solely on you. We will tell everyone that you are the person and the reason why Taproot is not on the network. So you better play nice. And also, if you keep advocating for it, we'll make sure that we scuttle any work that you do. And so that was kind of the messaging I was getting from people. I was like, okay, I thought we had version bits to do multiple things at the same time. But I guess, and I think, this was not a person who, made any sort of, admonishing comment, but he said, Bitcoin review, it's kind of like the Eye of Sauron, can see anything, but only one thing at a time. Maybe that's true, but I still think we could maybe do more than one of these things at the same time. So I kind of stepped back on trying to push it, and I said, I'll just wait for Taproot to happen. Meanwhile, I'll make Sapio, a programming language, and toolchain for not just CTV, but for any covenants, but works with pre-signed, works with CTV. And then if somebody made another covenant primitive and they could satisfy some constraints, they could also use it for that as well. I started thinking about this fee problem. We'll talk about that maybe a little bit later. Came up with transaction sponsors, which is a viewpoint that fees should just be completely isolated from application flow. Your application flow could be dealing with millions and millions of dollars, and the fees could be $10. So to deduct from your millions, you want exact logic on the monetary side, and you don't want any, let's just do some computation to figure out how much to deduct. Now you kind of want that to be very isolated, and you just want to be able to pay. Anyone should be able to pay. So I came up with this transaction sponsors mechanism that is now sort of available through ephemeral anchors today. And then I saw that Taproot just wasn't making progress, and it wasn't making progress for technical reasons. It wasn't making progress for people not being able to agree on consensus. And so I sort of decided I was going to appoint myself as the champion of Taproot activation. And there were some meetings that were happening, but people weren't like thinking about it pragmatically. We heard from Steve et al. Earlier about that. And like one of the things that I was really mad about is people be like, we're having a meeting tomorrow. And it'd be like if you're having a meeting and you're trying to do global consensus, maybe schedule it for 2 weeks so that everybody can plan, and maybe ask people to register comments in advance if they want to derail the whole conversation, so that we can say, okay, we'll consider your comment, but like don't show up in the middle of the meeting where we're discussing these 5 points and say something wild. So those meetings actually went really well. I kind of assumed this role. It's you volunteer into it. Okay, like I want Taproot to happen. Let's see what the problems are. And it kind of came to a head at a certain point. And there was just like not really like agreeing on how like the speedy trial should be architected with median time passed or with height. And the people who were like really arguing, they didn't actually really care, and it didn't really matter that much. Just like one thing had to be picked. And a bulk of the engineers, and it's been sort of made that claim that this was my fault, but I think Harding maybe proposed a coin flip. And it was, why don't we just like agree with like one path or another, and we'll just decide it by a coin flip if like the people who are like having this technical debate can't get on the same page about what it should be. Now, that coin did get flipped, and it did end up, I think, going in the direction that ultimately was chosen. However, also the like 2 people who are really like doing the work didn't like this that much, and so said, okay, let's actually like put our heads together and see if we can get to a compromise. And that was Ava Chow and AJ Towns, who kind of were on somewhat opposite sides, but came up with something that they thought was good enough, and everybody else at the meeting didn't really care, just wanted them to agree. What happened from there was like people, like Luke Jr. disagreed and said that wasn't right, but most every other dev said we don't really care, just like give us a client, and then a client emerged from there. Sort of in that time range, I also started publishing on connector outputs by the name of like coin delegation as like a general technique that what happens in like a lot of like the research community is people like are aware of these cool things you can do with Bitcoin, but they're not really aware of like what you can do with it. But they're just aware that like, oh, you can like do this thing, and I don't know from there. So this delegation, like I knew that I knew of it. When I mentioned it to other people, like, yeah, you can do that. It's not so useful, and that's why we want Graph-Fruit instead of that. But then sometime in the future, somebody figures out something really cool. So that I wrote this up, I published it, and then that idea is kind of what became this cornerstone of like arc of being like, oh, let's take these coin delegations and let's take these congestion control trees. Now you get something really cool. Similar thing happened with like Lamport signatures and script, where that became this like cornerstone of BitVM. So when you're aware of like one of these like mechanisms that you think is cool, even if you don't know what to do with it, you should publish it, and you should try and tell people about it, and people will tell you get lost, and then maybe a few years later you can be like, oh yeah, I told you about that thing. So around this time, we had I made a website for CTV, and people started saying if they were interested in it or not. Taproot had already like locked in, but I think not activated at this point. So I felt like it was like not disruptive to like start advancing CTV again. November 2021, Taproot activates. Everyone's really happy. I write this like 50,000 word blog post on like everything cool you can do with CTV and covenants. And then I start kicking up like a BIP review IRC meetings on the same sort of format and structure in some ways as the Taproot meetings. I write a post about the calculus of covenants, how we really should be thinking about covenants as like these algebraic operators and how those can compose, and that if you can't integrate your covenant idea nicely into this calculus of covenants framework, you don't really have a well-formed thing that people are going to be able to build with. And then I went to the one of the Bitcoin conferences, and everyone was just telling me like, you got to just put out a client. And some people were saying, oh, you shouldn't put out a client. What you should do is have a secret meeting with everyone who you think should be there. And that wasn't really my style. So I said, let's have, I'll just put out the activation client, also put out an anti-activation client. Because that seems to be what people want. Miners who I spoke with had communicated that they didn't really want to like get involved in the development process. But they would review like a static artifact. Like if you gave them a binary, they would test it, and they would see if it was something that they wanted to use, but not to like tell them to review a pull request. And then so somewhere in that, like the messaging got really confused. I think there were some people who were really pissed off about how Taproot activation went. And they, made it into this big, like, oh, this is an attack on Bitcoin. Some of the like key people who really should have like stepped in with like clarifying messages of like, no, covenants aren't bad. Just to be like, well, maybe covenants are going to mean the government takes over all of Bitcoin, and that's going to be really bad because they're going to turn it into, basically like, I don't know, a whitelist system where you can only move coins if the government says it's okay. So it got really weird. And that's something that I think is important, also as a lesson, because there's like weird, irrational, illogical people. One, are oftentimes rational people who are like outsourcing their expertise. And two, they can kind of come back at any time. It just takes like, is somebody going to like choose to be the bad actor and then say like, oh, like I want to like torpedo this idea. Let me get a massive trolls or something. And then now like into like more, modern history, just kind of continued doing research, built out like sort of, I didn't quit Bitcoin after I scuttled the activation attempt. I kept working, did some cool demos around how you could build like a layer 2 system on Bitcoin with pre-signed transactions because I felt like CTV was probably not going to happen. Got kind of burned out, reevaluated my life choices, decided I didn't want to contribute to Core. I still like Bitcoin, but like Core, I thought of, was maybe not an organization I wanted to be a part of. Then a little bit later, BitVM came out. I published these functional encryption covenants. Now there's Collider script, and I'm working on something called the Char network now, which is, in service of Bitcoin layer 2 orchestration. So that's kind of my like high level, low level, egotistical overview of like what was happening in 2017 that brought us through the last like 7 years of like covenant development. But like from my point of view, obviously there are things that I've left out, like L-enhance or vaults or TX hash. But I think that from my, sort of high level perspective, those are things that were kind of like always there. There's like the earlier like Johnson Lau work. People had talked, those things were kind of in the background. And when they resurface today, they're not, a lot of them aren't necessarily like particularly like new ideas, but it's like, can we get consensus on this idea? There's not like that much technical work happening from a like, is this a new way of using Bitcoin? Where that research is happening is on the application side, because the applications are really advancing. You're seeing BitVM, and then what does BitVM want? Well, they want CTV, and they maybe want like a couple other opcodes to do things. So the application layer is sort of where I think the covenant research is currently accelerating. The covenants themselves are like going to be the same until something gets activated. And then like zero knowledge proof stuff is like the next threshold there. So where that leaves us is like CTV really hasn't like changed. And that's the other title of this talk is like, why is CTV so sticky? It has not changed. Like there's been some changes to the code, rebasing it. People had like review comments of like change this variable name, or can you make this performance better? Sure, but like the code itself, the spec hasn't changed. And every other covenant proposal has like changed a lot. Like, people are like, oh, we're going to do TX hash and we're going to do checks from stack, but do we need to commit to it with a split signature? Do we need to, all these other things are changing, but why isn't CTV changing? It kind of just like hasn't had to, and this is from Peter's like blog post, is all that it's really doing is make sure the spending transaction matches the template. And everything else is more complicated than that. That's just a very basic operation. There's not really two ways to do that. It's like for opcat, if somebody said, oh, we want to concatenate the strings in the opposite order, it'd be like, okay, sure, it's like cool, but you can do that with a swap and then a cat. So it's like the same thing. And CTV, for anything that does a similar thing, it's just like the same result. So no one's really been like super motivated. And it did go through a lot of peer review. That's the other thing, is the evolution of CTV from Koshvi to CTV incorporated lots of feedback and review. So it addressed all these sort of like minor issues people might be interested in seeing resolved. Now, there's also kind of like this like ex post facto way of thinking about why CTV has been so sticky, which is that any on-chain trace of transactions that you see for any other covenant proposal can be really easily described by the equivalent sequence of CTV things. And if that was a path that when you made that covenant, you knew might get executed, you could have just committed to that. And a lot of other covenant opcodes don't necessarily have that exact sort of like flavor of you could do this Obviously, you can because it ends up being a signature or something, but it's a little bit harder to think about, okay, we saw some trace of transactions and now we're going to make that an op vault script instead. It doesn't really map quite the same. So that's one reason that CTV is kind of intellectually sticky, is when you're developing a protocol, ultimately you have to be able to deal in traces of transactions. And unless you need those transaction traces to be highly dynamic, then CTV works. And for the most part, with like where our, intellectual capacity is at for Bitcoin covenants, we end up dealing with static traces of transactions as being like, you need to know where you want the money to go at some point. Things like op vault, that's where it deviates a little bit, where it's like, oh, wouldn't it be nice to deposit to an address that you choose in the future? So that's kind of where like choosing in the future where it goes, yeah, that is nice, but it's more of a nice to have versus a necessary to have, because you can always set these things up in advance. And if you're going with pre-signed transactions, then you're really, really setting it up for an advance. This is kind of related, which is like if you build a primitive, and with that primitive you can't build CTV using that primitive somehow, then your primitive kind of isn't really good because it's too limited in what it can commit to be able to fully constrain a Bitcoin transaction. So you can't actually really make a full-fledged covenant. Every covenant primitive that comes out sort of has to be able to fully commit to as much as CTV does, or if you try to program with it, you're not going to be able to constrain your transactions appropriately, and you'll end up with like denial of service issues. You'll end up with all sorts of like weird, mempool bugs, and you also may like lose funds. So that's kind of why like CTV ends up being this really like there's this gravity well of like you have to be able to do CTV, and it's just kind of like this basic building block. I might kind of glaze over this. This I think will be kind of content will be covered a little bit more in some other talks, but there are these formalisms, and when people talk about, oh, we need to evaluate the covenants, is people need to work on this stuff. I'm not saying this is like the best formalism, but people need to make formalisms to evaluate these covenant proposals that can be like the common grounds, where you say, okay, I've got a new covenant proposal, and you could ask, well, like, what is the intent set of this covenant? What types of transactions can it generate? How big is that set? How flexible is it? What does the verifier for that look like? What does the prover look like for that? And when you do that, that sort of like makes it so that it's evaluable in a way against any others. And that includes things like trust models. So like, for example, functional encryption covenants, you have a trust model that at one point somebody set this up correctly. But also you have that same assumption in some senses for like a normal covenant that's an opcode with no trust assumption in the crypto. So you have to trust that it was implemented correctly, or you trust that the developer who wrote the software implemented correctly. And you can maybe audit that ex post facto, but it turns out that it's very hard to like how many people have like audited SecP to make sure that the crypto is correct there? Like, no one, a few people actually do that. So like a audited ceremony that people do can sometimes be, at least equivalent in practice to what people are relying on. So I'll skip over that. There's also kind of like this like reverse formalization is like, it's just like CTV always falls out. You end up kind of like trying to spec out, oh, I want this thing, and something like CTV just kind of comes. And so I think that's why like the narrative I gave you of like my whole history is really just to justify that like, I don't care about CTV. Like I've been working on covenants for a while, and CTV wasn't my like, oh, I've got a really big idea that's going to do all this cool stuff for Bitcoin. CTV was like, here's a crappy idea that does the bare minimum possible to get some like nice result. Maybe we can do that or use that as a discussion point. And also it turns out that it's very easy to implement rigorously CTV. So you can actually get a very high quality implementation, and you can make applications on it that are also easy to review. And so that's kind of like this, like CTV kind of falls out. It's easy enough. And like these other things, they end up going in like very vastly different directions when you start trying to say like, okay, well, what should a vault opcode look like? It's not really like you could make 30 different vault opcodes that people might prefer, but you end up with one CTV as a part of each one of those. So I guess the most interesting part is why did this fail to get in for so long? So I have a couple leading theories. Few people understood why covenants mattered. I've been harping on it for some time of like, oh, there's like congestion and like the network does not have capacity. So we really better have these smart contracting primitives to start handling more capacity. And we want composable primitives that you can come up with one good idea that solves one edge condition and combine it with another thing and then get something that solves like a much wider set of problems. but it's very hard to convince people of these things, because when you talk about a whole network operating in a different way than it operates today, it takes many leaps of faith of like, well, are we really going to have networks of people agreeing to sign together? Are we really going to see fees not always just go up? Are we? So there ends up being all these things, and then people didn't, the comprehensibility of why this was important wasn't really there, I think, until like ordinals. And ordinals, I think maybe that's because we imported a lot of people from like Ethereum community who understood why smart contracts were really important for like rollups and things like that. Maybe another one is like devs were not hot enough. I've gotten some compliments on Twitter, but I'm just a man. I've got a lot of detractors, people who like dislike me, or like I'm controversial, I'm mean, I'm Jewish. That's top one. I have a whole hate group. And then there's all sorts of like reasons of like just like any sort of like character assassination thing. Like that's like very common and very easy for people to be like, oh yeah, he's bad, and it doesn't. A lot of people just don't go beyond that surface. Yeah, very untrustworthy. So there's a lot of different things. Yeah, exactly. So that one, it sounds silly, but like actually it's like really serious. Like a lot of times, like, if I was like presenting something, be like, oh, it's just like another like weird idea Jeremy's putting out there. I'm not gonna like look at it, and it doesn't matter. And Taproot is all that, like, and he's detracted from Taproot, or he told CZ Binance that like he should try to do a reorg attempt. So he's like clearly like, all these things, but like it doesn't really matter when it comes to like a protocol primitive. The other one is like covenants are bad. That one like always ends up like kind of kicking up just because there's a lot of historical content and people like are very worried about the government taking over. CTV bad. In recent times, I think no one is on the CTV bad train. Very few. Like everybody has kind of realized that everything triangulates around something like CTV. So if you want to like be like CTV is bad, then you kill the whole project of covenants in general. So I think that one has sort of gone to bed at this point, but it wasn't before. Before there was a lot of CTV is just bad, and you could build something better, you could build something more complicated, and then everybody kind of comes back to, well, you can kind of just realize the zen of working with CTV and you get something pretty good. And then just sort of like the Taproot CTV thing, maybe in hindsight, I should have just told people to stuff it and like continued, like just going while Taproot was activating, and maybe that we'd be in a different place today. Because post Taproot, a lot of people were like, oh, we're just so exhausted from Taproot. We don't need anything. Let's figure out how to use Taproot. And part of the whole thing I said on Taproot is like, hey, like there's no wallets for Taproot. Why are we activating it? Like, why don't we develop out the wallets? And like, hey, I have like a cool, like, programming language. Here's an application. Like you could use this right now. I'd written like RPC calls, and there was more wallet software for CTV at the date of Taproot's activation than there was for Taproot, which is like wild. And then I think the other main reason is just like transaction level programming is confusing versus dynamic script. People really want to program in a programming language, and Bitcoin script is a programming language. So you can like write a normal program. Bitcoin transactions isn't really a programming language. It is a computation platform, and people don't like programming in computation platforms. It's like very weird and arcane and archaic. And so we figure out these like little bits of computation, like connector outputs is like an example. And then like I have like no clue what to do with them. I personally still don't really even know how ARC works. It's just like connector outputs. Like, yeah, like I published on an idea like that early, but then like, how does that connect to timeout trees exactly? Like, where is the money? It's very complicated. I could write a program in, let's say, a Solidity that implements the ARC logic, and I would get that because it's a programming language. Transactions, it's not really a programming language. And even like with Sapio, it's more of a hardware description language than a programming language. So I think that's one of the things that makes it really difficult for people to like get this stuff, and for like applications to get developed, because it's not a normal programming model. So where we're at now, and I'll wrap up. I think I'm nearing my time limit. Is that this doesn't really matter because we have covenants three ways anyways. We can have like the BitVM approach, which has its set of trade-offs possible today, complicated design, a lot of like interactivity. We have fucked up covenants, and that's a trust assumption, one-time setup, not like real today crypto, although maybe. I think we have some folks here who will say that it's doable imminently. And it's very simple on-chain, so that's like awesome. It's actually more efficient than CTV. For a long time, that was one of the reasons CTV was really sticky. and still is that like it's very difficult to come up with something that is as byte-wise efficient. I think Taj came up with one thing called exploding keys, which in some contexts is more efficient. But then if you want the most efficient version of CTV, it's kind of like, a little bit worse because you have like these elliptic curve operations you have to do. So it's like very, very hard. But the FDev Covenant stuff from an on-chain perspective ends up being like kind of the most efficient thing possible, which is like quite cool. And then we have now Collider script, which is definitely not like on-chain effective, but maybe can be combined with like sort of like a BitVM style fraud-proof thing, so you don't have to actually execute it in the bad path. So really cool. That's like recent research that I think you'll also hear more about. Expensive on-chain, and it's like possible today. It's just like going to be like a lot to implement and like very expensive to actually spend. So is there hope? That's not really for me to say. I'm just giving my history and perspective. Hope is for you guys to deliver. And I guess just like extra points that didn't really make the cut is like, my sage wisdom, and I can't really prove it to you, but like fees, I think if you're spending time on endogenous fees, you're wasting that time. Exogenous fees through like transaction sponsors or anchors are, I would say, without giving you like a full justification, like in all likelihood that is the only way that like with our like small brained ability to work with transaction level programming that will actually figure out things that work. Maybe at some point in the future, we can figure out all the mempool problems and MEV issues inherent to endogenous fees. But I think right now, think about like knowing exactly what transaction you want and then figuring out a way to pay for it is like a better way. And then lastly, I just want to point out that like in terms of activation, which largely not talked about, is that we're in a weird regime where we don't have a lead maintainer of Bitcoin Core. So I think this notion that like Core is going to do something, Core has only ever sent out any sort of fork with a lead maintainer, and there is not presently a lead maintainer. So I think when I think about like who has the mandate to deliver, when I was working on CTV, I actually said like, hey, as lead maintainer, what would you have me do? I like don't really care. I just want to do the next step that as lead maintainer you think is the right way. And I kind of got no response. And then that lead maintainer resigned and didn't name a successor. So the notion that like Bitcoin Core devs as like a set have any sort of authority, the ceremonial baton was snapped in half and doesn't really exist anymore. So, and like for the most part, the core devs who are maintainers right now don't necessarily have like really deep experience in forks, with the exception maybe being of HAL, like having like done the been pretty active with like speedy trial, but no one's really been on the side of like implementing the logic and activating it. So there's no expertise in it. So I think that it's going to have to be like the mandate exists elsewhere for activation clients. And I think that's intentional as a result of like core devs feeling like they want less responsibility and liability for the code base. And I'd be happy to be wrong, but that would take a statement from some of the maintainers explicitly stating what they believe their role to be in the fork process, and not people trying to observe it. It would be like an active step of saying, yes, we believe we're supposed to release an activation client. But I don't think that's happened. So that's all I got. I don't know if I have time for questions or if we should roll.
That was great.